Alright boys, I recorded a video on the usable practice test, but I don't know if that's legal to post that yet, so I'm just gonna record this real quick so I can just have a video for this week, and hopefully it's kind of helpful. I emailed the dude for the biology Olympiad. Hopefully she'll allow me to post the video, but we will see. But instead, while you guys are waiting, I'm just gonna do some AMC problems, and I'm just gonna do the AMC problems I didn't finish from last time, like 23 to 25 or whatever that I didn't finish. So let's just get into it. Hello everybody, I'm Kara, and today we are just going to be doing the 2020 AMC 10B problem that I did not get to, and the Livesolve is going to be very epic. Okay, so square ABCD has vertices at the points A, B, C, D. Okay, and you have either a rotation of 90 degrees left, rotation of 90 degrees right, reflection on the x-axis, and a reflection across the y-axis. Okay, but the positions of thing. Okay, so basically you want stuff that sends it back to its original location. Okay, this should be fun, I think, right? Okay, so essentially, reflecting, if you do a reflection, right, that means you can't rotate it. No matter how many times you rotate it, it's not going to go back to its original position. So if you do one reflection, you need at least 2 reflections in order to be able to rotate it back, right? 20 transformations. Okay, so that means you basically need an even number of reflections and an odd number of, an even number. Wait, what? Do you need an even number of rotations? Yeah, you only need an even number of rotations, right? Because you can either go left, right, or you could do like right, or even if you do reflections, right? If you do 2 vertical ones, then you don't need to rotate at all. If you do 2 horizontal ones, you don't need to rotate at all. If you do 1 vertical, 1 horizontal, then you have to rotate twice. So no matter what, you have to do an even number of rotations. Okay. So essentially, once you get to like 18 moves, you can never be, I don't know, wait, Okay, so basically once you get to 18, you could either be back at your original position, or you could be 2 away from your original position, right? There's no way for you to be 1 away from your original position, because we just proved that, like, after an even number of rotations, you should be able to get back to your original spot, right? So, essentially, we could do anything we want for the first 18, and then at the very last 2, then there's 2 options, right? Either we're 2 away from our original position, which means that, what? Well, okay, we can't do exactly anything. We need an even number of both. So, but then once we reach 18, it'll either be flipped, right? It'll be rotated by 180 degrees, or it'll be at the original position, in which case there are, what? Okay, let's first figure out how many ways there are to do this, right? So, essentially you could have, like, 0, 2, 4, all the way up till 18. You could either have this many number of reflections, right? And then, so that's basically 0 to 9, which is basically 10 options, right? So 10. And then times 2 to the 18, right? Because basically once you choose, I see. Okay, so you have to do, so you can either 10 choose 0, or 18 choose 0, times 2 to the 18, plus 18 choose 1, times 2 to the 18, and so on and so forth. Or 18 choose 2. So what is 18 choose 0 plus 18 choose 2? Is there a nice way to sum that? It's not like, It's not as nice as summing like all of them. So I guess if you have like 4 choose 0, 4 choose 2, 4 choose 4, then it is going to be 1 plus 6 plus 1, which is equal to 8. Then 6 choose 0, plus 6 choose 2, plus 6 choose 4, plus 6 choose 1. Oh, it's actually half? It's actually half of the total sum? Wait, seriously? That's cool? I mean, I did not know that. So that is 1 plus 6 times 15 plus 15. Oh, so it is. Okay, so then this is just like 2 to the 17, okay. So basically 2 to the 17 times 2 to the 18 ways to do the first 18. And then how many ways are there to finish it off, right? So let us say that it's in the initial position, then you could basically do left, right, right, left, flip, 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 flip. Either way. So that means there's 4 ways to do that. And then if you are over here, then you either go here, you go rotate, rotate, or you do flip, flip, or you do flip, flip. So there's also 4 ways. So then you just multiply this by 4. So 2 to the 35, 2 to the 37 should just be 2 to the 37, right? So A. Oh wait, this doesn't work because you might have like, it's odd, the number of like reflections is odd in the beginning, but at the very end it becomes even. So essentially what I think it is like basically you have like what was I gonna say? you basically have an odd. Let's say you go to 19, right? Then you're guaranteed to be one away from your original position, right? Because it's an odd number. There's no, like, literally there's no way to get to an, like, the only permutation that is 2 away from the original is if you're like flipped twice, so rotated 180 degrees. That's the only way you could be 2 away from your original position. Okay, wait, could you, like, what happens if you do, like, wait, so let us make sure, right? Because is there any way you could do an odd number of moves but be more than 1 move away from your original position? Because basically on every even, you're either 2 away or 0 away, and on every odd, you're only 1 away. There's no way to be 3 moves away, right? Is there any, like, permutation that's 3 moves away? Yeah, I'm pretty sure you can't, because, like, just based on what we were doing, right? Yeah, basically the point is, whenever you make, like, an odd number of moves, you're always going to be at least, like, maximum 1. There's no way to be 3 away from your original position, no matter, like, in an odd number of moves. So, that basically means that we could just do anything for the first 19 moves, right? 4 to the 19, and then the last one just doesn't matter. Like, the last one is just whatever brings you back to the original position. And also, another thing to notice is that you can't be at your initial position after an odd number of moves, right? Because at the beginning we were talking about how you need an even number of moves to get back. So, then we basically just noticed that the answer is 4 to the 19, which is 2 to the 38. So let us check that. Hey, very nice, okay. Okay, how many positive integers satisfy that nonsense? Oh, I hate the floor, dude. I hate the floor, god dang it. Okay, so basically we need this to be an integer, right? So we need it to be 0 mod 70. What's 1000 mod 70? Divided by 70, 130, 308, or 4, 280. So 20 mod 70, okay? So then we need to add 50, at least. Or 50 plus 70k has to be n. So n has to be 50 plus 70k. And if we put this in, what is 105 over 70? That's just 15? 15, right? Yeah. 15 plus 70k is equal to the root of root 50 plus 70k. So essentially this, like, your square root is approximately 45 less than your square. And essentially as you increase it, your distance between your square and your actual number is going to increase. So we basically need something that's approximately 45, and it should be around there. Okay, so let's just say it is 1, in which case you basically have, like, wait, what? No, what? Hold up. Wait, there's no way, right? Because, okay, so let's just say it's 0, so 15 root 50. It's not even close. Wait, 15 and a square are way bigger than that much apart, so I don't get how this is going to work. Hold up. Shouldn't it be 50 plus 70k? There's literally no way other. Oh, plus k, oh. Divide by 70. Okay, that makes a lot more sense. Alright, so then that should work. Okay. So how do you do this? So I guess basically what it's saying is that 15 plus k squared is approximately 50 plus 70k. So essentially k squared plus 30k plus 225 is equal to 50 plus 70k. Basically gives you k squared minus 40k plus 175 is equal to 0. Does this factor nicely? So this is 25 times 7. I doubt. Oh, 35. Oh, it does. Hey, k minus 35 times k minus 5 is equal to 0. So k is approximately 5 and 35. So it'll just be some stuff around there, otherwise it won't be approximately equal. So let's just test it out. So 35 and 5 for sure work. Okay, we can just test it out. So 35 works for sure because it's exactly equal. So this is 50. This is 35 times 70, which is what? How am I supposed to do that? Well, okay, we know that's equal. So does 36 work? Wait, actually, is that true? Okay, let's just test it out. 34 times 70. Let's get rid of all this nonsense. 34 times 70, 0, 8223 plus 50. 2430. And then 34 squared. Wait, what's 35 squared? No, wait, no. So this should be 51. So 4, it was 50 squared, 25. Oh, 49 squared. Okay, so that's true. That's right, right? It should be greater than 49 squared. Okay, that seems right. And then we need the next one to be greater than 51 squared root. It's 30 or 33. What's 33? 70. So this minus 70. Oh, wait. Oh, okay, I see. So basically the squares go down by 49, but the number goes down by 70. So this doesn't work, right? Because 49 squared is going to be bigger than that, right? So 1, 8, 36, 44. Okay, so right now it's at 35 and 5. That's the only one that we know work. And then 0, 6, 3, 19. Okay. 1, 0, 1, 4, 2. Wait, what? Really? So 99? Oh, okay. So it goes down by 99. So then 34 and 33 should also work because it'll go down by like 97. Because it'll go down by 97 and then this will go down by 70. But then if you go down another, it should still work. So 32 should work too. However, if you go up, it won't work because it'll go up by 70, except the square will go up by 101. So that's not going to work, right? 2500 to 2601, really? 2601 squared? Really? I did not know. Oh, I guess it is, yeah. Yeah, it is. Okay. I did not know that. Okay. So these are all valid. So this is minus 90. So, okay, so you have minus 99, minus 97, minus 99. That works. Then minus 97. Okay, let's see. So we basically need the lower bound on this, but I'm pretty sure it's just going to be 6. It's not going to be this big for sure. Yeah, it cannot possibly be that big unless, could it? No, it's like, it's at least by 20s. So yeah, okay. So I'm just going to go with 6 and no need to do it out fully. Hey, very good. Alright. And finally, number 25. One of you guys said that number 25 was not that bad. I don't know. One of you guys commented about this. Let's see how it goes. Alright. Number of ways to do this, okay? So they're basically integers strictly greater than 1, and the order matters, okay? Oh, that seems nasty, dude. I guess you could do recursion, right? So, oh, I guess it is recursion, right? So it's basically going to be like, okay, so let's just see what the factors are. So it's 2 to the 4, 2 to the 6, right? 32 times 3, 2 to the 6 times 3. Wait, what? 2 to the 5, okay, 2 to the 5 times 3. So, that basically gives you 1, 2, 3, 4, 6, 8, 12, 16. How many should you get? 10, 5, 6 times 2 is 12. So 24, 32, and what? 48 and 96. Okay, so we this is nasty recursion though, huh? Okay, so there's 1 for this way, right? Or yeah, because that's gonna be d of 1, which is, or k is greater than, yeah, because there's one way to do that. 42, then you have d of 2, and there's only one way to put it 2 down. Okay. Then the d of 3, that should also be a 1. 4. So how many ways are there to do 4? You can either have 4 by itself. So there's 2 ways to do that. 6 were given. There are 3 ways to do that. Okay, this is not even an option. 12. So that gives you 8. How many ways are there to do 8? So you got 1. You could do, okay, so you could do 8. You could do 2 times 4, 4 times 2, or you could do 2 times 2 times 2. Anything else? I doubt it. Okay, seems legit. So that is 4 ways to do that. Then 12. So 12 you could do 1, 2, 3, 4, 6, 12. Okay, so we already did these. So this is going to be 1, 1, 1, 3. Alright. So then 12 is just a sum of these guys. So that is going to be 8. Alright. Then 16 is just going to be 1, 2, 4, 8. So it's going to be 1, 1, 2. Alright. So there's 4 ways to do that. Wait, how many? Okay, so we saw there are 8 ways. Or 4 ways to do 8? Okay, so 4 there. Alright. So that is going to be 7, 8. So 8 ways to do 16. Then 32, you just add this here, and then to be 1, 1, and then 16 we got was 8. So that's just 8. So you can add 8 onto 16. So that is 16 for this guy right here. Then 48. Wait, 4 times 24. Oh, so this is 16 over the next one. Oh yeah, because this is just 24, you add this, you shift this over, and then this one is just going to be 12. So yeah, that should be times 2 from that. 16 times 6 versus, okay, I'm assuming, I'll take my word for it. Okay, that seems right. Okay, 2 and 48. So 48 is twice 24, so that should just be, add this in here, so it's twice that. So it should be 32. Okay, so now we just sum up all this. So 32, 64, 16, 80, 84, 84 plus this whole thing should be 8. So 92. No, that's not even an option. What? Okay, wait. So let's just think about this, right? So if you have 3, there's one way to do that. But if you multiply it by 2, and you go to 6, then, oh, so you had to add in a 2 at the front. So you add a 2 on this side, and then you have 6 there. Alright, okay, so you have 2 and 3 are options for dividing. Okay, so 6, so that's 1. That is going to be 2. Or, sorry, this is 1. So if you sum these, you get 3. Then if you go to 12, what do you get? So you get 12, 6, 4. So this is 1, this is 1, this is 1, because it's going to be 2, 3. Oh, and then this is, okay, so 1, 2, 3. But then this is going to be 4, in which case, and 4 we know is 4 options for that, right? Because you could do 4, 2, 4, so there's 4 ways to do, oh wait, what? There's 2 ways to do that, because you could do 4 or 2 times 2. And then for 6, we know there were 3 ways. Okay, so we just need to keep track of this instead of dying each time. Okay, so what happens if we multiply this by 2 again? Then you get 24, 12, or 24 times 2, 12, 3, 8, 4, 6. So we have 1, 2, 3, and then 4 we know is, or 1, 1, 1, 3, and then, wait, what? 1, 1, 1, 2 for 4, and then, so oh yeah, 4 is 2, then 6 is 3, then 12 we know is 8, sorry, this is 8, so what is 8? 8 we got is 4, so it should be 4, and this should be 8, okay. We just write this the other way so it's clear. So 1, 1, 1, 2, 3, or 2. Oh, okay, so it'll be 1 and then take out that. Okay, so 1, 1, 1, 2, 3, 4, 8. Okay. And then sum of this will give you 24, which gives you what? 5, 12, 17, plus 8, 20. Right? Yeah, 20. So 24 is 20. Then we do 48. So that'll be 1, 2, 3, 4, 6, 8. Oh, really? That's it? Okay, 16, 48. So the only new thing we have is 16, which is just 1, 2, 4, 8. Some of those. And we know 1, 2, 4, 8 is 1, 1, 2, 4. So this is just going to be 8 for 16. So that's 8. Then we know the rest already. Oh, 16, 24. Okay, and then this is going to be 24 is 20. So we just sum this whole thing up. So basically this plus 8, because we got a 16 in there. So 28 plus 20 is 48. Oh, really? Okay, that works. This part's 20, this, okay, 48. And then 96 is 1, 2, 3, 4, 6, 8, 12. Nice. Okay, 16, 24, 48, 96. So basically this whole thing plus another 48. So this is 48. Do we add in another thing? Oh, 32. We need 32 somewhere. 32 gets added in here. And 32 is just going to be 16, 32, so that should just be 16. So you basically do 48 times 2 plus 16 gives us 96 plus 16. It's 112. Okay, let's test that. Okay, I better be right. Hey, we did it! Finally, let's go! Yeah, so basically it's recursion, right? I kind of didn't explain that very well. Basically what I was saying is like, if you have the factors, right, you could basically just set the first one to be one of the factors, like 1, and then you had to multiply by like d of 96, or no, 1 is not an option. You could do 2 times d of 32, that's one option, right? Or like 2, if the first factor is 2, you have d of 32 ways to do the rest. If the next one's 3, then there's d of, d of 32 here and 48 here. And then if you do 4 as your first factor, then there's d of, like, what? 96 over 4, which is 24, right? And so on and so forth, and that's how I did it. And we got A is 112. Alright, we're finally done. Alright. I hope that was helpful. Thank you guys so much for watching. As always, if you enjoyed the video, leave a like and subscribe for more. But that is all I got for you guys today. Let me know what else you guys want to see in the comments below. But other than that, thank you guys for watching again, and see you guys next time.